All right, good morning and happy Thursday. It's July 27th, and I'm planning on doing the LeetCode Daily Challenge for today. So let's see what happens here. Usually LeetCode has more difficult ones here at the end of the month, so no guarantees. Usually I don't get the fourth question during contest, so we'll see. Usually these ones are hard, so okay. Maximum running time in computers. Okay, looks like I tried this one like a year and a half ago. Okay, in computers, an array of batteries. Okay, each minute we consume one from the battery. Okay, so this one seems like a greedy algorithm, right? So we can greedily, here's the game plan, greedily consume the largest batteries first. I'm gonna bigger batteries there in. Okay, now I see why this is going to TLE. I'm pretty sure if I use a priority queue, it's going to TLE. So how do we identify the bottleneck then? Yeah, I mean, I missed this one before. I don't know, maybe I'll look at the hints, but as of now, I mean, my first reaction is we are continually extracting maximums. Okay, and then subtracting one from each. Right, so whenever we continually extract minimums or maximums, the heap, right, slash priority queue is part of the algorithmic toolbox that can handle that in logarithmic time. Anyhow, I'm pretty sure this will TLE though, because that's what happened previously in Kotlin, right? Previous attempt in Kotlin, and results TLE. Okay, well, anyhow, we'll just try this and see what happens, right? Q and this guy. Actually, let's do this. Just call this guy Q. How about heapify it in place? Heapify the Q. Oops. Okay, and then true. Turn total T equals 0. Oh, I see what we can potentially do, right? Potential optimization is to take more than one at a time, right? T plus equals 1. This will result in TLE. So I need to find out what's the biggest I can take at a time and add that chunk. That's one possible way of doing this. Another consideration is binary search. What about binary search? Right, just make a logarithmic amount of guesses at a cost or runtime cost. Linear scan for guess for validation. Maybe. Okay, well, let's see what happens here. Okay, so we got heap fire queue. That's actually a min heap, right? So actually, let's do this. Hack a max heap. Q equals negative x for x and a. Heapify the queue. Okay. underscore and range in X is top of the heap. X plus equals 1 if X heap push X if X is not equals 0. Since X is negative. If not length of the queue at any point, then return T here. Okay, something like that. 4 and 2 is what we're expecting. First test case works. Second test case works. Okay, let's see what happens. 825 to 831. 6 minutes. Looks like it's going to TLE. Oops, wrong answer. So it's an incorrect solution. Let's see what's going on here. All right, so +1 bug. Oops. Oops. There. Okay, so output's 9, but we expect 8. The queue before each run. And 1035. There's 3 of these things pulling from it. Oops. Three. So 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. The heck? Why is this 8? Is there 9? One into each computer. Okay. So what we take. Okay, we'll put it back at the end. the ones that we took, right? All right, so what we took, we'll push it at the end after we consume the rest of these, right? So we can't use the same battery more than once, and that was why, oops, that's why I had the bug. Let's do this. Yeah, do this. Oops, I don't need that debug print, but I'm pretty sure that's the root cause of this failure. Let's try this again. All right, so push it after we take from each. Oopsie, push down to the queue. Whatever we took. Okay, that looks good. Make sure we don't have any regressions. Okay. 8:35. About 4 minutes. Oops. Hit debug. Let's fix. Okay, now it's TLA. Okay. And yeah, that's what we'd expect since this is quadratic, right? Okay. Yeah, so I have a working solution. It's just too slow because n can be 100,000. Right, so this seems more promising than maybe binary search. Okay, let's just say this is our target. Can we meet that or not? Okay, I don't want to waste time though. So I don't get Q4 hards in contest. And I think it's because of my grit is actually working against me. Like if I don't look at other people's solutions, I'm not going to learn. Right. So I don't want to keep being ignorant, but I don't want to just like, and there's a balance, right? You don't want to just look at the solution and say, oh, okay, of course, that's how you do it. And let's look at this. Okay, solutions. Let's see, hints. It's 8:37 in the AM. I'll take a look at the hint. Okay, well, all right. Maybe I shouldn't have looked at the hints and I should have just done the binary search. Okay. Yeah, usually when it's like, okay, I'm totally stuck, then we have to reach into our algorithmic toolbox and say, hey, you know, this strategy isn't working because of that. And then, okay, completely different strategy. Right. So binary search was the correct intuition based on the hints. So let's do the implementation. Looked at hints and my second guess, right? And for game plan. That's correct. That is binary search. Okay, so let's implement this and then let's move on, right? So having some total like this, we'll have a total be our search space, which is ij, and return I at the end here. Okay. 0, and then j will be, what will j be? The maximum value of a, perhaps? All right, that's the upper bound. K is I plus j divided by 2. If okay is okay, then I equals j. Oops, I equals k. Otherwise, g is k minus 1. Okay. Okay. So to check if it's okay, I guess we can consume it this way, right? We can. Well, I don't know if this is okay or not. Quadratic times logarithmic. I don't know. It's pushing it. Well, let's just see what happens. So I don't have to reinvent the wheel, right? Return t is less than or equal to our threshold k. Okay, let's see what happens. Oh, q is not defined. Q is negative x for x in A, and it needs to be heapified. Okay. That's what we, oops. Total, which is accumulated based on our Q. Or wait, no, K is less than or equal, right? The total days. So, okay, hold on. So maximum runtime. Okay, so if we're saying this is okay, then our total has to meet or exceed it. If the length of what we can take is less than n, then we break. Otherwise, we're cool. Push them all into the heap, increment the total, at the end return the days can meet or exceed our threshold k. KO and length q is at least in wait, right. What's going on here? We have at least in the queue. Right after you consume it, leftovers. And it looks like take all in at once, right? With the total t. Yeah. Okay. I don't know where it's getting stuck. Print search space I to J. S is K. Here's no good. So I guess we can just run one test. Oops. Okay, let's just run this first test. How about see what's going on here? Okay, so I started at 8:37, right? 8:37. Right now it's 8:44. Just trying to track where my time goes here. 8 minutes. Okay, 0 to 3 is our initial search space. Oops, hold on. Guess one. One is okay. Right? Yeah, okay. Guess two. Two is okay. Guess two. Two is okay. Guess two. Okay. Alrighty. Let's try this again. It's three. Three is okay, but four is okay too. Right? Or is not okay? Let's do this. Right. Okay. Four. Oops. If it's not okay. Oh, it is. It's true. What the heck? Okay. Which is not okay. And we have to make it smaller. Oh, J is the maximum with this, which is not correct. Okay. J, how about the sum of that then? Sum of that divided by n, maybe? 6, 9. Okay, yeah, divided by n. Okay, that works. So my upper bound was off, and then let's make sure we don't have any regressions here. Oops. Okay. Okay, that looks good. This is binary search. That seems okay, right? Let's see. Let me just comment out the print statements for now, and then we'll submit it and see what happens. Big money, no whammies. It's 8:47. Oops. 8:47. Let's see what happens. It's taking a long time. Uh-oh. Okay. It's still TLE. Oh, dang. This one TLE is on a much smaller test case. Looks like things have gotten worse. I did binary search. Way that I'm checking if it's okay is a quadratic solution. I need to make okay linear. Right. So the question, oops, anyhow, is like, okay. Oops. TLE again. Is that plus 3 bugs? All right. And the question here is how to form validation in linear time. Is okay is currently quadratic. Results in TLE, right? We take more than one at a time. right, let's do this. Take equals heap pop on the Q. Pop the top. That's negative. And then, okay, so let's let's make it negative again. The highest value will be the maximum of what we can take. Or no, the lowest. Because this is what we have. And we can take the minimum of what we have from each, right? Take what we have T, which is our total, is incremented by what we can take. Oops, hold on. Let's do this. So for X and what we can take, keep push Q. If X minus 1 exceeds 0, then keep push onto the Q, negative X minus 1. Make a negative again because it's a max heap, which is a total hack. But now we're taking more than one at a time, right? We're taking the minimum we can. And I think that helps. Right? Oh, intake. Oops, what we have. Our X minus take. It has to be greater than 0, right? So it's the minimum of what we have. X minus take, and then negate that. X equals take. Take more than one at a time. Okay, I think that looks right. Thought. T take. Oh, these are not looking right. It's taking like way too long. Okay, let's see what's going on here. Oh, wait, hold on. If X minus take exceeds 0, it must strictly exceed 0. Okay, that makes sense. Otherwise, we just take and keep going negative. Okay, so that's not right. Take the minimum of what we have. Oh, here we're taking 3 at a time. 3 to 3, and we have nothing left. Dang it. Okay, so that doesn't work. This doesn't work. Okay, yeah, so this seems like the key question, right? I still need to figure this out. Kind of a form of validation, linear time. Right, you can't take more than one. Not optimally take more than one time. Okay. Well, that sucks. All right, I'm going to dwell on this a little bit longer. I'll post this. It's something I failed on, but I mean, at least I did get this part right. The intuition of just like guessing. Right. So you gotta count the small wins and if and when they do occur, I guess. Some of the hardest parts of leak coding or problem solving is identifying viable or feasible algorithms and data structures, right? That'll work in the amount of time given the input and the problem statement. Yeah, it's a good challenge. Yeah, I still have a lot of work to do. It's oh man, these are billion too, so that doesn't make anything any easier. If that thing's a billion for a linear solution like this, I wonder a binary search within a binary search, maybe. Yeah. I don't know. It's getting like super complicated. So I have to also remember to keep it super simple, right? KISS. Keep it super simple. Okay, well, I'm gonna take a break and look at this again today afternoon. Or maybe I'll look at it next year. All right. Well, I'll catch y'all later.